Hello, and welcome to this lesson in quantitative reasoning where we're talking about consumer mathematics. We're going to talk about the Consumer Price Index and inflation. This is an application of percent change. This is an application that you will hear about in the news from time to time. They talk about the Fed wanting to keep willing to keep interest rates low because inflation isn't high or inflation's going up, so they might want to make it a little harder to get money because they think that's part of the reason is so, everybody can raise their prices because there's enough money available to be borrowed. So this ties into things that do affect our everyday life, and I'd like to explain a little bit about it and give us more practice with percent change. So these slides were provided by our textbook publisher. I did make a couple corrections, but here they are. So consumer price index is what CPI means, and inflation. Inflation is the rate at which prices, the cost of living kind of increases. Although it isn't exactly called the cost of living. Inflation is related to that though. So we're going to talk about the consumer price index to calculate the rate of inflation. And that's basically what we're going to do. We're going to talk about what the consumer price index is, how the Bureau of Labor and Statistics figures it out. And I did put a link in our course website to that site where you can actually drill down to see it. We'll do that in class. But inflation is a general and ongoing rise in the level of all prices in the entire economy. When my parents bought a house in 1955, I think it was, or 54, they bought a house and they paid $12,000 for it, which was then an outrageous amount of money. It was several years' income, many years' income. $12,000. But, wages were lower when prices were lower. And in 2004, that house sold for $250,000. Now it's the same house. So inflation is the measure of how much your money will buy. If as prices inflate, you need more money to buy the same things. And it typically always tends to go up. We've been in a period of flat inflation at the time frame I'm making this video right now for a little while. It's not been really high, but there have been other times in history where the rate of inflation was crazy high. But over a period of years, it always is noticeable. So inflation is a general and ongoing rise in the level of all prices in the entire economy. So prices of a variety of goods and services are combined into a single price level, and the inflation rate is based on the percentage change of this bucket of variety of goods, or basket they call it. Economists use a basket of goods and services, things that individuals in businesses would typically buy. They're broken into categories, as we'll see, and they track the cost to have that same basket of goods bought today as compared to bought a year ago or bought a month ago or bought a quarter ago, depending on what data they want to look at. So the rate of inflation is when the prices go up. Deflation is when they go down. It's a percent change of the consumer price index over time. Now, you don't hear much about deflation. It does happen in particular sectors. For example, the price of gas fluctuates. I mean, if you go back to the years when my son got his license 13 years ago or something, the price of gas was $4 a gallon. And if I drive by the gas pump today, it's like $1.85. So that's deflation. It's gone down. But not everything has gone down. The price of housing has gone up. The price of food has gone up. So the consumer price index, the overall inflation hasn't necessarily gone down, but parts of it might, and other parts might go up. So if you have the price index values for two different time frames, now last year versus this year, the year 2010, the year 2020, we can calculate the rate of inflation as the change. If it's positive, it's inflation, as the change in the index divided by the initial value of the index. This is a rate of change problem. This is the newer number, or the final number, the number you're looking at the end, minus the initial number. In the other videos, that's what we call them. Or we did new minus old, however you refer that. And you always divide by the original, either the initial or the old. Notice these two match. And then you multiply by 100. This fraction itself is relative to 1. You want to make it relative to 100 because we're going to call it a percent. But that number on the bottom has to be the beginning number, not the ending number. So suppose the CPI, they add up the basket of goods, and it's $105 in 2010. And that same basket of goods in 2011 cost you $107. And it's really dollars and cents. So it's $107.10. You can think of it that way, 107.1. It's a consumer price index. It's not reflected in dollars, but that's essentially what they're valuing. So what cost you $105 in 2010 now costs $107.10 in 2011. This is the more current value. This is the final value that goes there. The initial value goes there and in the bottom. You do the subtraction first by order of operations. This fraction bar also means there's parentheses around the top. If you type into your calculator, you will get 106.1. Sorry, 102.1. 102.1. No, you won't get 102.1. Yeah, you will. You get 100. Sorry, start again. Get 107.1. It'll do, division is done first before subtraction, so that'll be 1. You'll get 106.1. That won't be right. This fraction bar implies grouping of the top. So you do this first, 107.1 minus 105. That'll give you 2.1, and then you do 2.1 divided by 105. Be very careful if you're using a calculator and you're trying to do all of this in one step. I don't recommend it. I recommend doing the top first. But if you do it in one step, you must put that in parentheses in the top. Okay? So when you do that, you get 2.1% is what you would have gotten. They did 2%. Well, I guess 2.1 divided by 105 times 100 will then give you the 2%. That's correct, 2%. So it's a 2% inflation rate. But that's not per year. That's over. Oh, yeah, that is per year because it's from 1 year to the next year. If you did it over 2 years, you would have to say over 2 years, or an average of 1% per year or something like that. But the CPI comes from the price of a quantity of goods. And they may even do it by different regions, or they may do it across the whole country. But it's just a basket of goods, and that typically we'll see what the categories are in a moment. So if the CPI in year A is 102 and in year B, they don't give you years, is 112.2, the rate of inflation from A to B, assuming they're just 1 year apart, the rate for that many years, you do the new minus the old over the old, and you get 10% in that case. Okay? That's just another percent change. And again, these have to be in parentheses. So if the cost of a dozen ears of corn went from $4 to $3.50 in 2018, so the beginning of 2018 they were $4. In 2000 they were $4. In 2018 they were $3.50. Over the rate of deflation over that 18-year period was negative because $3.50 was the newer amount. So you did $3.50 minus 4 divided by 4. It was a negative 12.5%. If you wanted to make that per year, you would have to divide by the 18 years. But in 18 years, the price of corn fell by 12.5%. And again, the stuff in the top has to be in parentheses. So this consumer price index is the most commonly cited measure of inflation. And it's not quite the same as the cost of living, because the cost of living represents how much it costs for a person to feel that his or her consumption gives them an equal level to what they had before. And depending on what you're looking at around you, that might change. Like, I did not have a computer in 1980. It didn't bother me. Nobody had a computer in 1980. But if I could not afford a computer now, that would be more of a cost of living. Like if I didn't have one now, I would feel like my living situation wasn't as good. So that's a little different measure. But the consumer price index is a measure that's commonly cited for inflation. So the U.S. Bureau of Labor Statistics calculates this. They calculate all kinds of things. So they decide on, like, what are they going to add to their shopping cart, that they're going to take the price now and the price later, or the price now and the price before, and compare. So they have to compare the cost of this basket of goods in 2 different time frames. So they do a survey to figure out what kinds of things people spend their money on. And they end up breaking this up into 8 major groups. So currently they use 1982 to 84 as the base period. So they use that basket of goods. It's probably time to update that, in my opinion, but it is just an opinion. So food and beverage, we all have eat and drink. That includes full service meals. And if you go to their website, they'll drill it down to food eaten at home compared to food eaten in restaurants. And it looks like it's about 50-50, which is funny because of my own budgeting. That seems to be about where we spend our money, half at home, half in restaurants. We don't eat out half the time, but it's more expensive when we go to restaurants. Housing, renter's cost, homeowner's cost of housing, fuel oil, you have to heat the house, you have to have furniture. So the basic furniture is what they count. Apparel, stuff you have to wear, clothing. Transportation, the cost of a new vehicle, flying, gasoline, motor vehicle insurance. Medical care is in there. Recreation, televisions, cable TV, pets, pet products, sports equipment, ticket prices, things like that are in there. Education and communication, college tuition, postage, telephone services, computer software, and accessories. So if that is still in there, maybe even though it starts in 1984 or whenever, that's probably pretty valid still. Other goods and services, tobacco, smoking products, haircuts, other personal services, funeral expenses, all of those are wrapped into this 8th category. And they weigh the categories differently because, let's face it, we spend more on food in our life than we do on recreation. And hopefully more than you spend on medical care too. So the food and beverage is 15.3%. The housing cost, they weigh as 41% of that basket. So they take the average cost and they come up with 100% of a cost by making this a weighted average. So 41% is housing. The next highest percent is transportation at 16.8%. Because, well, it doesn't cost that much to take the train or bus. Well, it kind of does, especially if you own a car. So in flying and things like that is in there. And then food and beverage. And then these other things weigh in a bit less. So when members of the media, the news, discuss inflation statistics, when politicians talk about it, they measure relative to the consumer price index. And the way they measure inflation, it's a percent change. It's the new period amount minus the old divided by the old times 100. You've done that before. And again, the top of this you have to figure out first before you divide. You should put it in parentheses when you use your calculator. So, which of the 8 components of the consumer price index is the highest? It's housing. It's far more than anything else. So let's do a practice calculation as another percent change practice. Let's say a typical household in the United States consumes 1 loaf of bread, 2 gallons of milk, and a dozen eggs. Well, that's not my house. There's only 2 of us. We don't pretty much 0 milk and no bread. But anyway, the prices for the different years are here. So you had 2 gallons of milk, so you're going to multiply that. So the price in 2014 was $2.50 plus 2 times $3.50 plus $1.50. And we're going to calculate for 2014, there was my total cost of that food basket. For 2018, here's the total cost. So the consumer price index inflation rate over those 4 years, now keep in mind that won't be per year, they'll be per those 4 years, is the 18 minus the 11. 18, the new minus the old, divided by the old, times 100, or 63.63% if your basket only included those things. Now, there are other things in the actual consumer price index basket, so it might not be the same number if you use the entire basket, but that is the idea. Statisticians figure out what the prices are for these things, and then they calculate, today's compared to last year's, or 10 years ago, or 5 years ago. You do hear these things as news articles. You read about them in newspapers. You hear about them in news broadcasts. So that's where that comes from. It's just another application of percent change. All right, thank you for joining me in this lesson in quantitative reasoning, and I'll see you in class.